calculator give us the equation, right? Okay, so that is absolutely what you would want to do here. Hello. Yeah, she's okay. Thanks. Bye. I keep thinking about what the honors. What is that? AP US History?
Yuck. Literally the only favorite class.
We keep thinking about getting t-shirts for my religion class. I teach one religion class. It's Religion 9.
Why don't we get...
But the design that they requested, I don't think would work well. The design that they requested, they wanted my face very large, like right here.
Yes.
And then above that, in sort of a caption, what did they want? It wanted it to say like, no, something about using your brain good. Like has use our brain good. I think that's what it was. And then on the back, I don't remember. I'm like, guys, I don't.
That's an awesome sweatshirt. I want one.
It may be an awesome sweatshirt, but I just don't think
the same face that one of the snowman was going on the shirt.
That's the face that motivated me.
Yeah. Can we get sweatshirts? Algebra 2 sweatshirts. Yes. And just have that. Have a snowman with your face. Little and then we can have a button that we push and it talks and it says like equation.
Yeah, we could do that. Let's take number 16 as our example, okay? And we will take a little bit of extra time with number 16. We'll do it on a calculator. I will show you how to do it by hand just so you can understand it, and then we will leave that method behind.
Yes.
Now, you have been given 3 points. You've been given 3 points for number 16. X, 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 Y, Y, Y. So you put the X's in. 1, 2, 5. You should have your calculator, somewhere in the vicinity of your desk if you have it with you. Then the Y's, 2, minus 1, and 2. So if you need to calculate an equation, all you have to do, as you'll recall from yesterday, is stat, calculate, go down to choice 5, quadratic regression. Now, what we've got here is an answer. We have y equals 1x squared minus 6x plus 7. Now that's not a lot of work at all. That's why I showed you the calculator method only yesterday, because this is how you do it. I mean, look, people don't program computers with punch cards anymore, okay? People don't do this by hand anymore either. You use your graphing calculator for a reason. That being said, I do want to show you, Karen, what do you need? Oh, your calculator, okay. I do want to show you how this would work by hand, because you can follow along. The steps aren't very hard at all. So here's how this would work by hand, okay? So you would take these 3 points, 1, 2. I'm going to actually space them out across the board like this. 2, minus 1, and then 5, 2. And you know that this is the form y equals ax squared plus bx plus c that we are going to then substitute the points into. So you do it one at a time, and it would look like this. If this is your x and this is your y, you'd go, okay, y equals ax squared plus bx plus c. Substituting that coordinate in. And you would get 2 equals, well, that looks like a 9. That's a plus b plus c. This is your first equation. There are 3 missing pieces. In order to solve an equation with 3 variables, you need how many equations? 3. 3, which is why, in order to write the equation for a parabola, you must have 3 points, not 2. You make a line with 2 points for a parabola, you need 3 points. Now I'm going to do it again with this guy. Y equals ax squared plus bx plus c. That is minus 1 equals, that's 4a plus 2b plus c. There's my second equation with the same 3 variables. And now finally, y equals ax squared plus bx plus c. That simplifies to 2 equals, that's 25a plus 5b plus c. So what I have is I now have 3 equations in 3 unknowns. And so I'm going to take them all here, and I'm going to write them right next to each other so we can see them, okay? I'm going to write it this way. A plus b plus c equals 2 is the first one. Here I have 4a plus 2b plus c equals minus 1. And here I have 25a plus 5b plus c equals 2. Now, trying to remember maybe some of the stuff that we've done before in this class, have there been any methods that maybe we spent, I don't know, a whole chapter on learning how to quickly solve a system of equations like this? Matrices. You could substitute, you could, but that's a lot more algebra steps. We learned chapter 4 for a reason. Now, what I would suggest, I'm going to use, and you got to kind of jog your memory here for this, I'm going to use the row reduction method where you put the coefficients in one side, a little extra column for the constants. 1a, 1b, 1c equals 2. 4a, 2b, 1c equals minus 1. 25a, 5b, 1c equals 2. Now, I'm going to take my calculator here, and second matrix, go to edit. That is a 3-row by 4-column matrix. Let's see, 1, 1, 1, 2 for the first one. 4, 2, 1, minus 1 for the second one. 25, 5, 1, 2 for the last one. Okay, now I'm going to quit out of there. I'm going to go second matrix, go to math. Anybody remember where I'm looking? RREF. Do you remember what that stands for?
Reduced echelon form.
Reduced row echelon form. Pretty close. I would like to put matrix A in that form, and I get this. That means my answer, first of all, it did successfully put it in reduced row echelon form. I have 1s on the main diagonal, 0s everywhere else. That means this is A, this is B, and this is C. So y equals 1x squared plus, not plus because B is minus 6, minus 6x plus 7, which is exactly the work that your calculator did behind the scenes, except it obviously does it faster. I'm not going to make you do this by hand, but none of these steps are too hard for you. It's just plug in 3 points, get 3 equations, remember something from last semester that lets you solve it real quick. This is the math behind it. But you will allow your calculator to do that work. Okay? So other than anything from these, because I would expect you to use your calculator to calculate this for you, what else would you like to do, John?
So could we have used our calculator to do basically the same thing last semester, but we don't know?
Yes, you could. We did, John, we did substitution and elimination last semester. We only rarely did it with something, with a system this big, 3 equations, 3 unknowns, because it's fairly annoying to do that by hand. But we needed to at least do it a few times, which we did. We then learned matrices, which we never really did. We never did this row reduction stuff by hand. The point is to do this fast. Anything smaller than this, like 2 equations with 2 unknowns, we usually worked out by hand because it tends to be pretty fast. That's what I remember from last semester anyway. Is that what you remember?
Yeah.
Oh, good, because that's what we did. What else would you like to do from this, if anything? 21, then what are you going to say?
Either 12 picking the person.
Okay. All right, let's start with 21. Now, 21 is an interesting problem. All of these down here, all of these say, write a function rule, that's an equation, write a function for each situation, and identify, is the relationship linear, quadratic, or neither? Well, neither. That's weird. What? Whoops. Sorry. Don't change the aspect ratio. Okay. Linear. Guys. Linear is any equation that can be forced into that form, right?
Yes.
Quadratic is any function, I should say, that can be forced into that form. The big difference, obviously, is linear has only an x to the first power, and quadratic has an x to the second power. That's the big difference. If you get something that fits neither of these, well, then that would be neither. Now we'll look at a neither example in a second, but let's just look at 21. It says the area of a triangle with a constant height given its base length b. Well, you have to think back geometry just real quick. The area of a triangle is, of course, 1/2 times base times height. Now, this is neither at the moment, because how many variables do you see? Let's count again, class. 3. Which is why they say a constant height. So plug it, they're like, hey, plug in something for height. Do they tell you what? No, they don't tell you what. Just as an example, I'm going to make up a value for height. Let's make our triangle be
5.
Okay, 5 units tall. It doesn't matter as long as we pick a number and hold it constant, because that's what they say. Well, that would of course look like this. The area would be 1/2 times the base times the height. So area equals, that's 5/2 b. Now there's my function. Which one is that?
That is linear.
Linear. It's got a variable that you plug in, an input variable, an x, in this case the base. It's got an output variable, in this case the area, and it's not missing any other pieces. Remember, these aren't variables, that's a slope and a y-intercept, right? This is linear. Now, some of the other ones, however, look, the circumference of a bicycle wheel given its radius r, circumference is linear. It's 2 times pi times r. What about the area of a carpet needed for square rooms of length? The function for the area is side squared. Side squared, because it's a square room, length times width, side squared. That's quadratic, because you see the degree 2, you see the power 2. One that would have been neither is the bacteria one, and we'll see why. Bacteria one is kind of interesting. Yeah, that's what they do. You've got the population of a bacteria. Let's say it starts out with one little bacterium. An hour goes by. What do you do?
2.
Then another hour goes by.
Oh, that's
And another hour, and another hour, and another hour. And you do this for double for each hour. Right. Now, have you ever, in all of your years of math, come up with any kind of weird notation if you have to multiply the same thing over and over by itself?
the scientific No, it's the I. It's 2 repeating.
Overthinking this, what is it?
2 times power.
The power, exponents. You use, if you have to multiply the same thing by itself over and over and over, we use exponents as a shortcut for repeated multiplication.
The I thing is like 10 times 9 times 8 times 6.
That's factorial, yeah. So look, you multiply the 2, you double it for however many hours that you're going to go. If you're going to wait 50 hours, this 2 needs to show up 50 times. So guess what? This is 2 to the power of t. Is this linear? Is it quadratic? No, it's neither. This is actually an exponential function, which we haven't even dealt with yet. It doesn't fit into either of those 2 categories. This is therefore a tricky problem for us at this point, and it's neither. Yeah, it's an exponential function. They're different. Just to see what they look like. Look, here's your basic linear function. Here's your basic, right? Here's your basic quadratic function. And here's your basic let's go with 2 to the x. Here's your basic exponential function. So linear, quadratic.
No way.
So this guy apparently is doing something like this. It's like this weird L-shaped curve. We're going to have a whole chapter on these, but just not right now. It falls into neither the linear nor the quadratic category. It's its own separate thing. Just FYI, I'm not going to give you like test questions about these kinds of problems. I just think they're interesting, and you should look at them. The material from this section that's most important is, can you take points, plug them into your calculator, get an answer? When you do that, can you then plug in something else, like year 2015, and get an answer? Do we need to do 19 or anything like that, or no? We do? Okay. Just real fast, we'll do that, and then we'll get quizzes passed out, and then we'll start doing that. By the way, the quizzes were quite good. I'll tell you what the average was in a minute. But overall, they were pretty good. Okay. Let me clear all this other stuff here. Stat edit. Let me clear this data. The table shows the amount spent on water guarding in the United States between 1999 and 2003. Find a quadratic model for the annual amount of millions of dollars spent on water guarding based on the number of years since 1999. Based on the number of years since 1999. Now, this sentence, guys, this sentence can make this more tricky. We have to think about how this thing. If you ignore that sentence and just put these in your calculator as the ordered pair, no. You'd be okay. You'd be fine. You'd get the right answer. But if we're going to really listen to what the problem says, technically, they didn't want us to do that because they wanted us to base it on the year 1999. The number of years since 1999. So the value that would go with 1999 would be 0, because that's like your starting point. This would be 1. This would be 2. This would be 3. This would be 4. The year 2015 is how many years away from 1999? So we're going to get 16 comma something in a second. Now, if you didn't do it that way, if you just entered in the 4-digit years, you would be okay. But I'm going to do it the precise way that they said. So, 0, 1, 2, 3, 4. Slide over. 8:06, 9:43, 12:05, 14:41, 15:65. Double check. Yep. See, that's why I just double check there, because one little mistake like that, and you'll have a bad day. Okay. So, turn on my scatter plot. Zoom 9. There it is. There it is. Now, I'm definitely going to need to not only calculate the parabola through this, but get it to display on here, because after all, I need to plug in a number and have it calculate something for me. So, walking through the steps we've been through many times: stat, calculate, choice 5, quad regression, variables, y variables, function. Of course, these are all online for you. There is my equation if I needed it, or my function. Here's my graph. It looks kind of like a straight line, but you can tell it is curving slightly. If you zoomed out, you'd see the curve better. But it's like this kind of big, really slow, sweeping parabola. Now, how do I plug in an x-coordinate and get the y to go with it? I go second and trace. And I want value. Plug in 16. I get an error because I've not apparently zoomed out far enough. So I'll just zoom out. There you can see the curve of the parabola a little bit more now. Second trace value, 16. Okay. Excuse me. I got to zoom out one more time, I guess. That's okay. My picture now looks horrible, but that's not my concern at this point. Second trace, value, 16, $3,293.83. That is exactly the answer, by the way. That is exactly the answer that you would have gotten to 90, let's go 94. If you would have ignored this sentence underlined in red and used the 4-digit U. Because that would have changed the scale of your graph, but it would not have changed the meaning of the graph. It would not have changed its value. It would not have changed anything that actually matters. Okay. Can you pass this in, please? Please, please, please. Thank you.